need to return both human-readable content and structured machine data from the same AI tool. You'll see how to use ToolResult for complete control over your FastMCP tool's output, combining text summaries with JSON data and execution metadata in a single response. This pattern gives you explicit control over all aspects of the tool's output: traditional content blocks for display, structured data for programmatic use, and metadata for debugging or performance tracking.
From FastMCP Tools tool, import ToolResult. From MCP, types import text content. At MCP, tool. Def Advanced tool, ToolResult. Tool with full control over output. Return ToolResult. Content equals text content, type equals text, text equals human-readable summary. Structured content equals data. Value, count, 42. Meta equals execution time ms, 145.
This demonstrates the structured tool response pattern, where a single function call can return both human-readable content and machine-processable data. The pattern uses a dedicated result container to explicitly separate presentation content from structured data and execution metadata. What makes this distinctive is its ability to satisfy both UI display needs and programmatic processing requirements in one response. The approach works by encapsulating all response components in a typed container object. This design principle maintains clean separation of concerns. Your tool logic focuses on business operations, while the framework handles content formatting, schema validation, and metadata injection. The declarative nature of this pattern means you specify what to return rather than how to format it, letting the framework handle serialization and protocol compliance. This pattern matters because it solves the dual output problem common in AI integrations. Clients need both display-ready content for users and structured data for downstream processing, but generating both manually creates boilerplate. The container approach eliminates this redundancy while ensuring type safety and schema compliance. It's particularly valuable when building tools that feed into both human workflows and automated systems, though it does require understanding the framework's response model upfront. Let's break it down line by line.
From FastMCP Tools tool, import ToolResult.
This imports ToolResult, the standardized return type for FastMCP tools. It enforces consistent output structure across all AI callable functions, combining human-readable content with machine-processable data.
From MCP, types import text content.
This imports text content, a structured type for tool outputs that enforces consistent formatting. It standardizes how text responses are packaged, ensuring AI models receive properly typed content with metadata like content type.
At MCP, tool. Def Advanced tool, ToolResult. Tool with full control over output.
The @MCP tool Decorator registers this function as an AI callable tool in FastMCP. It transforms the function signature, docstring, and return type into a structured schema that AI models use to understand and invoke the tool. This is the standard pattern for exposing Python functions to AI workflows, where the Decorator handles serialization, validation, and execution tracking automatically.
Return ToolResult.
This returns a structured ToolResult object, the standardized response format for FastMCP tools. It packages human-readable content, structured data, and metadata into a single response, ensuring consistent handling by the AI framework.
Content equals text content, type equals text, text equals human-readable summary.
This defines the human-readable output of the tool, using FastMCP's text content type. The type equals text field declares this as plain text content, while text carries the actual message that will be displayed to users or logged in the system. This pattern ensures tools can return both structured data for programmatic use and human-friendly summaries.
Structured content equals data. Value, count, 42.
This defines structured machine-readable output, separate from human-readable content. AI models and downstream systems parse this dictionary for programmatic use, enabling reliable data extraction without text parsing.
Meta equals execution time MS, 145.
The meta field captures non-content metadata about tool execution. Here it records the 145 ms execution time, enabling performance monitoring and debugging without polluting the primary output. This pattern keeps operational metrics separate from business data. This closes the ToolResult instantiation, finalizing the structured response. Without this, Python would expect continuation, causing a syntax error. Tool output control pattern. The ToolResult object gives you explicit control over all aspects of a tool's output: traditional content, structured data, and metadata, while maintaining compatibility with MCP clients. Omitting both content and structured content will raise a validation error, even if meta is provided. Use this pattern when you need to separate human-readable output from machine-processable data in a single response.
The tool that speaks in 3 voices is heard by none, yet understood by all.